Green means go. And good to go. Cool beans. So, welcome back. Coming down on the last week next week before we have our finals week. So, there's 1 week left. And we'll be done with this probably on Monday. That'll give us Tuesday, Wednesday, Thursday to do some last minute studying for this. Test Friday, sound about right? Yeah? That'll be plenty of time for this, won't it? And then we'll try to get some review in for Monday, Tuesday, Wednesday finals week for the final exam for everything. And then the final on whatever day it is. Okay? So today we're doing the multiplicative inverse and matrix equations. Just like every operation in mathematics has an inverse, so do matrices. You know, opposite of multiplying is what undoes multiplication is division. What undoes addition is subtraction. And then we have some other type of inverse type things. So that's what we'll be doing today. So we probably won't be able to do the encode decode messages, which is kind of fun. But if we get there, we get there. If we don't, then it's okay. But we do definitely want to make sure that we can get an inverse, and then to use the inverse to solve a matrix. You guys ready? Nope. Last. So, tutoring, as long as there's tutoring sessions, you can do retakes. So next week it'll be Monday, Tuesday, Thursday. Finals week, there'll be tutoring Monday, Tuesday. So you have 5 more chances. I know I was supposed to cut you off in November, but I couldn't bring myself to do that. So I'll take you all the way to finals week for any retakes or stuff, okay? All right. So let's take a look at a matrix that's going to produce for us the inverse matrix, okay? This is, well, let me just show them to you. You're going to recognize this, hopefully, and you're like, oh, really? That's kind of cool. There it is. So these are called the multiplicative identities. You know how when you multiply by 1, you get that identity back? But if we're looking for the multiplicative identity, the inverse of it, we're going to multiply by a matrix that has a main diagonal of 1s. Everything above is 0, everything below is 0. That's pretty interesting, huh?
And what does this accomplish?
So what this will do is we'll take a matrix, we'll multiply it by one of these multiplicative identity matrices, and then what comes out of it is going to be the inverse. So remember that when we did inverse functions? There was a function and its inverse, and that would undo that function. You remember that? And then we would get back y equals x. This is going to do the same thing for us. So we can have a matrix. So that means that we can have a system. We can multiply it by this bad guy, and then we can get the inverse matrix, the one that will undo the original matrix.
So wait, the one you have to multiply it by is?
This is what we multiply by.
Yeah, so but if it's like a 2 by 2, you can only multiply by 2 by 2.
Correct.
Okay.
Yeah, so fantastic point. You're only going to be able to find inverses of square matrices. Square matrices. So if you have like a 2 by 3, you're not going to be able to find that inverse of it, okay? Because we're always going to be multiplied by this multiplicative identity matrix of order length. It's not as hot today, huh? I'm still thirsty though.
Wait, why can't you find the multiplicative in your...
Of a 2 by 3?
Yeah.
Because every time that we want to find an inverse matrix, we have to multiply by a square matrix with a main diagonal of 1s. Okay? If I had a 2 by 3, then I would have 1, 0, 0, 1. That's all I could really do with it, right? Does this have a main diagonal of 1s? No. So it has to be a square matrix. Okay? Thank you for asking. Any other questions? Any other questions? the sweater.
Oh yeah, I wore it today.
That's the favorite.
It's like, how do you get that?
I know. Well, that you can just make it up. So, like, if I told you, hey, you know what? I've got a 4x4 matrix. what would the multiplicative one look like? Well, if it's, I'm just thinking like, dang, that's a lot of work. But if it's a 4x4, then I would have 1, 1, 2, 3. Then I would have 0, 1, 1, 2, 0, 0, 1, 0, 0, 0, 0, 1. So this is not the hard part. I can find the multiplicative identity matrix of order n. This is the 4x4. That's a 3x3. That's a 2x2.
And when you multiply, it has to be like how we did before, right?
Yeah.
Where it's like you have to do like the column.
Rows, columns, correct. Right. So yeah, we probably won't do a lot of those.
Is that the inverse of that?
No.
No.
Oh.
No, these are the key to getting the inverse. So let's go and see how that works, okay? So here's what's going to happen.
Oh, so if you had 2 by 2, you multiply that one.
Yeah. Yes.
2 by 2 by that one.
Waterfalls.
That's why you can always split it.
Do you want to ask your question one more time?
So if you had a 2 by 2, you multiply it by.
If I had a 2x2 matrix and I multiplied it by this,
You would get the inverse.
I would get the inverse.
Oh, okay, so you can do it with anyone, you just have to know those. It's just a line.
Yes, you need to know those. Now, here's the thing. So if I'm taking some matrix, I don't know what it is. Let's go 3, 2, 1, 5. And I multiply it by this guy, 1, 0, 0, 1. I will get the inverse matrix. Do you guys remember that -1 inverse? Okay? So if I take some matrix, multiply it by that multiplicative identity, I'm going to get this. On that same note, Haley, if I take some matrix and I multiply it by the inverse matrix, or the supposed inverse matrix, what should I get? I should get the multiplicative identity matrix. So if this was true, if this was a 2x2, and this is a 2x2, and they were in fact inverses, then I should get back 1, 0, 0, 1. Does that make sense? Give me a thumbs up if that makes sense to you. Thumbs down if you don't. Sideways if it's a little bit. And that's what this slide is saying here. Take any two supposed inverses, and you're going to get back that identity thing, or that multiplicative identity.
Okay, so a-1 is the
Yeah,
1.
anything to the exponent of -1 is not the power of -1, it's the inverse. Okay? Yes.
What is
Wait,
it?
so this is a-1? Or the outcome of this multiplied by the matrix?
A matrix times that multiplicative identity. A matrix times the multiplicative identity
Is
will
a-
produce an inverse.
And then, okay, got you.
And if I take this times this, then I'll get this. You had a question, Courtney?
Yeah. What is N?
What is n? N is the order of it. So if it's like an order 2, an order 3, it's 3x3, 4x4, 5x5.
So, what would go in the N below the I, like the sub I?
Well, what is, give me a dimension for this matrix.
2 by 3.
It can't be 2x3. We just said that.
Oh yeah, 3 by 4.
Can't be a 3x4. We just said that. It has to be a square matrix.
Okay, so 2 by 2.
So if it was a 2x2, then this would be I sub 2. It's telling me that my,
Oh, so it has to be the same.
yeah,
Oh,
they always have to be the same. Okay, we're good? So this is all just theoretical so far. Let's see what it looks like, right? Well, not theoretical. These are just the rules. Let's see what this is going to look like. You guys ready?
Yeah.
Booyah. So, show that these two, show that B is the multiplicative inverse of A. What should I expect to get when I multiply the two?
B.
No, I'm multiplying these two to check if they're inverse. What should I get?
1, 0, 0, 1.
I should get this. You guys ready? Now, I'm going to do a little maneuvering here real quick, because I can. Where's my camera picture?
Business now.
Down here. As opposed to writing up there.
I thought it being
Being underwater with this tea is so loud, you still hear it. Very cute.
Waterfalls. Okay, so coming up to the board. Finding the first element here, first row, first column. That's 2 plus a negative 1. What is that? 1. Now I'm going to go here. That is the first row, second column. I've got negative 2 plus 2. How much? 0. Looking good so far, right? Now we're going to go here. That is a second row, first column. 1 times 1 plus, that's a 0. And then finally, second row, second column. I've got negative 1 plus 2. How much is that? Did I get the matrix? Then are these inverse? They are.
What was that concept?
Oh, you were gone yesterday, huh? Can everybody finish this up? Can I, if I erase it? I'm gonna do it one more.
I want to take a picture.
So B is the inverse of A. And we know that
Because that came out that way. That's it. Okay.
Getting yelled at by Miss Bettina while you're underwater is.
So you're gonna want to take a look at yesterday's video. It should be on the channel. But the way you multiply these matrices is gonna be a row. You have to make sure that these dimensions match, and you'll get this dimension out. Okay. In this case, it's a 2 by 2 with a 2 by 2. Because these match, we're going to get a 2 by 2 out of it. Okay. So now the way you multiply them is going to be rows by columns.
The best part of swim was swimming.
So we're going to take, to get the first one, this is in the first row, first column, right? So we're going to multiply. Oh, that hurt in my, did you hear it pop?
No, I heard you almost break the
It's right there. Ask Lauren and Kennedy. They're probably better candidates.
Isn't the slide right above?
No.
My favorite memory.
Like that, it's gone.
Oh, yeah, it's gone.
It's gone.
Yeah, that's it.
So first row, first column, I'm going to take the first row and the first column. And I'm going to kind of sweep my way across. So these two is a product of 2, right? And I'm going to add to that the product of the next 2. That's 1. Okay. Let me do this one. I'm going to jump around for you, okay? This is the second row, second column, right? So I'm going to take the second row, second column. That's negative 1 plus 2. How much is that? That's 1. Let me do this position. That is in the first row, second column. So I'm going to take the first row values with the second column values. Start it off. That's negative 2 plus 2. How much is that? 0. And then finally, we're going to do that one. It would be this one with this one, right? So it'd be 1. What the heck did I just write?
Plus.
1 plus a negative 1, which is 0. And because this is that multiplicative matrix, then these are inverse of each other.
A clear row here. Completely changed direction.
You guys good?
Here.
All right. Here's our next one. I want us to find. What up? Let's go back here. Thumbs up, thumbs down. We're good or not good? I want to do this. Let's do the fist of 5. 5, I can cheat somebody. 4, I can do it by myself.
Body. Sorry.
Wait, what is 5?
5 is I can cheat somebody.
What's 4?
4 is like I can do it, but I'm not teaching nobody.
Yes. I can buy
0 is like I'm lost. Okay. This is just practice that you need there, Kennedy? Just some practice.
This is like super hard.
Right.
Yeah, I feel
That's
like
what it comes down to. All right. Thank you. Waterfalls. We're gonna find. We're going after this guy. We're going after him. You guys ready? Let's bet. How do I do that?
I can do it.
How do I find A inverse? What do I need to multiply by?
Sit up here right now. This bit, front and center.
Yeah,
No.
if you want to. We're going to multiply by this guy, which is the multiplicative identity, right?
1, 0, 0.
Absolutely. So we're going to multiply this guy by 1, 0. Whoa, that's not what I want. That's what I wanted to do. That's exactly what I wanted to do. So this guy will. This guy should be. Ralph. We're going to multiply by this guy. That's going to produce for us A inverse. You guys ready? You do it. You do it.
Oh, I was gonna say, okay.
I was going to do it, but no, you do it.
I wrote my favorite too, Mike. It's just
Okay.
I wrote my favorite one.
First.
Okay, bad memory. I love from school.
Okay. So when you want to find
Plug in that, you plug in the
so we're finding
1, 0, 0,
right? So what is the algebra? Like what is it? What row and column? What is that called? First row column. Row one column, right? So you have that right. Row one. Oh God. Row one column. But you're multiplying to this spot.
How's it fall? I'll be right there. Say that you're
No,
all
three and one. Yeah, so three and one. Oh, you add it? And one. It's not one. That's not what. Oh, you add them? I thought you multiply them.
One year I was just multitask for everybody.
Okay.
I just go around and just like, wow.
I thought you kissing you. Okay, yeah, that's.
Wow, this is my floor right now.
You guys are part of it.
Swim was anything but swim. It was pretty good.
The only thing I didn't like about swim was actually having to swim.
And then
So where is this? This is the first row, second column, right? So you take the first row with the second column.
Actually, the only thing I didn't like about swim was
okay, so now, what do you want to find next? So what would be just that one? Row one. Of this one.
Well, go ahead. I'll be right there. She did have her hand up first. What's up?
What is that?
So yes. Well,
Yes. The multiplicative inverse and order. What's up, Ben?
check my notes.
Three plus
Right? I thought you asked how nice it is.
Don Munoz. Are you telling us a lie? I think I'm telling you a lie. Hold on.
Come on.
No.
Okay, I have a CD. That wasn't even with you.
They got
So then just
It's
right,
okay.
that's what you're supposed to use.
But I also
I'm not bugging.
What? You don't have it. Wait, go back. You remember that one before that? Let's find it out.
Bro, now you don't understand what I'm saying, bro.
Wait, this no, it's not what I mean.
No?
No,
Okay.
the next slide. The next slide.
Underlined it and stared at it.
Which one is that?
No, I'm doing something different.
Okay. Wait, that's not. Wait, Mr. Munoz. So when you're multiplying to find row 1, column 1, you do.
Hold on, I think I did it wrong. Hold on.
Yeah, that's right.
Hold on.
We were finding it's not listed.
Okay, now you can see. So go ahead. You know how to do it.
Can we redo that one? Because I
Yes,
just
please.
was
You better have a trick.
It's depressed. Wait. All Evan does is text me.
Hold on.
You have to add 2 plus 1 8.
So confused. Wait, are we
But it would be 0. Because 1 times 3 times 1 plus 1. No, you don't multiply. Plus, and then it's 1 plus 0. Zero?
Well, hold on. I'm missing the slide. That's what happened here. Hold on.
No, you did 3 times 0 and then 2 times negative 1. Or negative 2 times 1 and then you add the 2. Right?
No, I'm saying what I did for here. This is wrong.
We're all talking about different things.
Yeah. It can't be that one.
Just so I confused.
No, that's my fault because I deleted the slide somehow. Here, let's go back real quick. Here. I'm missing a slide here. Let me add. Go back to here. Here we go. All right. Your attention, please. I have to go back and apologize. I'm missing a slide, which took me in the wrong direction. Let me write this down real quick for you. I know. This sucks. I'm sorry.
What did you guys get for the first row 1, column 1? 3, right? Yeah, I was right. 3 times 0, 3 times 1.
Oh, I wrote it down. Yeah, I did.
Oh, yeah, you did.
That was like a year ago, bro.
Stupid.
Wait. I wrote it wrong. So it is 3.
Yeah, I split it.
Doesn't make any sense.
I said 4. Can teach you.
Never mind, I'm back to the 4. I can't do
Oh, what's it?
Wait, I just need to recap on the working multiplication. I got
No, we do need a. We need a. I must have when I hit that thing, I must have deleted more than one slide. Waterfalls. Okay, so let me go to the top because when I elbowed my thing, I must have deleted more than one slide. So we were trying to do the multiplicative inverses, right? This is how you're going to check if they're multiplicative inverses. So when you multiply the two, you should end up with that multiplicative identity, correct? Then I said, hey, we need to go find one. I said, this is the way we're going to do it. That's not true. That's not true. Let me go ahead and write this down. This is how you have to do to find the inverse. Okay? It is pretty easy.
Wait, so you were right though on seeing if it was the inverse?
Yeah, so see if there were inverses, it was that one. Here, think about this real quick. Do you guys remember what the rule is for, let's do 5 times 1. What does that equal? It equals 5, right? Because this was called the multiplicative identity of 5. So when we multiply by an identity, aka 1, then we're just going to get that same matrix back. Okay, just like this case. So 5 times 1 just gives us 5. Some matrix times that diagonal of 1 is the same idea. We're just going to get back that same matrix. But when we do multiply the two matrices, we should get back this identity. Okay? Because that's just like multiplying by 1. to get an inverse, we have to follow this process. Okay? So if we have some matrix with A, B, C, D in it, then we're going to do, you guys remember when we did the diagonals for the solving systems? Same idea. So this is A times D minus B times C. And they're going to multiply by D, negative B, negative C, A. I'm going to show you the easiest way to get it in a little bit. So, go ahead.
I forgot how to do that.
I apologize. That's my fault. I had to come
Wait,
check.
can you just recap how to multiply again? Because I don't have my notes from you. I don't have my notes from you.
Well, for this, you're just going to do the diagonal products.
No, like regular multiplying two matrices together. Just give me like what you do for row 1, column 1, or something.
Row 1, column 1, this times that, and plus this times that.
So 2 times 1.
So
plus
here we
1
would
times
do
0.
2 plus 0, which is 2. To get the next one, we would go, that's second row, first row, second column. So 2 plus 1.
Wait.
No, that's 0. JK, smiley face. So it'd be 1.
LOL smiley face.
LOL, smiley face. Here we would go this row, this column, that's 1, plus 0, 1.
It makes a lot. Okay.
Okay?
Yeah. Okay. Wow, my brain just did not connect those two zeros.
You would just leave your brain said all information. I would not, yeah, I would need it.
It raised us all
We're
done.
gonna take the matrix and then multiply it times that.
We're going to go through this process, correct? So here's my matrix. I want to go through this process. So let me copy.
It's the third one. I have to put that for you.
It's 1.
So we would do 1 over 3 minus 3. Oh, that's plus 3, right? 2, right? And then that's AD.
Where's the D?
D's right here.
Okay, so it's 1
So
times.
it's A, B, C, D. And then here we're going to do A, B, C, D.
So this is how to find the inverse.
Right. So this is going to be, so this is going to go here. It's going to be 1, and then 3. Should be from here, right? 1, 3, and this should be negative 2, and this should be negative 1. Should be the opposites. Should be the opposites of those.
But that's B, so B should be negative 2 over here, and then it should be 2 over there.
Do you hear me?
Oh, B and C are in the same spots.
Yeah.
B and C are the same spots. So this is 1, and that's 2.
Oh, so only DNA.
So only DNA swap.
But the B and C would be negative. Would you say?
Right. And then this is 1, right? So 1 times that is just that. That's my inverse.
So that's how to find it, and the one before was how to check it.
I'll check it.
Okay.
So that's the inverse of that.
So the
So
inverse,
if you were to multiply the 2, you would get 1, 0, 0, 1.
let's check it.
Check
Okay.
it.
Okay. I'm going to double check this formula.
Double check.
Double check.
I'm double, triple checking because I already made one mistake and I don't want to make it again.
Chaotic right
I'm gonna triple check.
It's 1 over AD minus BC. And in the matrix, I've got D, negative B, negative C, A. D, negative B, negative C, A. Yes, good. Okay.
Our answer was zero.
Okay.
Wait, so then A is negative 1.
There was another way to do this.
Is it easier? This actually isn't really that bad.
How did you get
Geography or
what you would
It's just
it's just like plugging stuff in.
Let me try something else.
So like this is, let me do something else.
No. I'll do something else in a little bit. You guys want to check it, right?
I want to take a picture of it.
Wait, so what's the answer?
That's the inverse right here.
So what was the point in doing that?
That sets me up for the inverse. All of this sets up for the inverse.
So you have to multiply it by, because like sometimes that might be like a 2 or something. You
Yeah,
multiply the whole thing.
this might give you a scalar to multiply that by. So we're gonna check it right now. You guys ready?
Oh, it equals 1 in this case, so it's negative.
Right.
But if that equals 2, then you have to go
I have double everything. Right. Let's see here.
That was good, good. Put everybody's head together.
Do you have this other matrix? Do you have this matrix?
Yeah.
Okay, spit it out.
What?
What is it? 3, -2, -1, 1. All right.
Should I keep grabbing?
So let's see here. We have 3 plus a -2, which is 1. Then we have 6 plus -6, 0. Then we have -1 plus 1, 0. And then finally we have -2 plus 3, 1. So yes, there they are.
So now can you like explain how you did it?
That's right there, the formula. Right, the green. This is A, this is B, this is C, this is D. So you're gonna go 1 over this product minus this product. And then over here you gotta swap these and then do the opposite of those.
So then, what do you do with that? You multiply it by that one?
Yeah, this would be a multiplier. But it's a 1, so does that change anything? No.
Wait, what? I didn't math.
But I want to do something else. What's up?
Is the formula for the inverse and the 1 over 80 minus BC multiplied by
That's the formula for an inverse. Okay? Hey guys, when there's like 10 minutes to the bell, please let me know because I want to show you something, the fastest way we're going to do it.
Faster way.
Yeah, there's always a faster way.
Why don't we show?
Calculators.
See how much I opened
Then everything would be
so
half of
much?
that. So you multiply it even half, 1, 1.5. Okay? Read me this matrix one more time. Read me this matrix one more time. It was 3, -2, -1, 1? 1, 0, 0, 1. Row swap. Yeah. Times -1.
Oh, yeah. Feel it. I feel my brain cells going. They're all
Times 3 added to row 2. So we have 3, -3, 0, -3. Zero, 1,
It's on a mission.
0, no. 3, 1. This should be 1, right? 1, and this should be 3. And then I want that to be 0. So I'm going to multiply this by row 2. Multiply by. Oh, I just got to add it. Add it to row 1.
Oh, yeah.
Oh, hold on. That's all right. So 0 plus 1 is 1. 1 plus -1 is 0. 1 plus 0 is 1. 3 plus that is 2. Right? And then this would be 0, 1, 1, 3.
I'm not cheap.
Is that the same one? Waterfalls! It's been, I can't believe I still remembered this. So, this is what I thought we were going to do. So your book is offering you this method to find your inverse. Okay? It's the formula. It's 1 over the product of these two minus the product of those two. Then in this matrix, you're going to swap the A and D, and then put the opposites of B and C in there. And then once you go through the math, you'll get the inverse. Thank you. So you can write this formula down. The way that I was shown in college is when you put the matrix with the identity next to it, and then you do row operations. And what you're doing is you want the identity to move to the left side. And once you do that through row operations, the identity ends up being the inverse. So what I did with this guy is put into reduced row echelon form, right, through row operations. And as I do those operations, let me go a full page. As I do all those operations, the right side becomes the inverse. So I start with A here and have the identity over here. And through row operations, I turn this into the identity. And what's left on the other side is the inverse. I started with the matrix, and I put next to it the multiplicative order matrix. With row operations, I start to turn this guy into the identity, right? That main diagonal of 0, 1s. That's what I care about. Whatever ends up on the other side is the inverse.
So you just turn it into one big matrix?
Yeah, I turn it to one long matrix, and then you do row operations. You make the original matrix through row operations. You turn it into the identity, and the other guy will end up
So
being
does it
your
almost
inverse.
become like one matrix kind of? In a
Yeah.
way?
So whatever I do to this row has to happen to everything in it. Right?
Oh yeah.
So here the first thing I did was to swap the rows. So this row went to the top. See it?
So it's like now a 2 by 4.
Right. So essentially it's a 2 by 4. And then I multiplied by -3, and then added them to row 2. Then there's values. It became this. And then finally I added 0 there. Got the inverse there. Now, waterfalls. I don't care which of those two methods you choose. You need to pick one so that you can get good at it. There might be some questions on Math Excel. But after we got our hands on this bad boy, which is, for those people that can't see the TID4, here's what I'm going to do. I'm going to go over to Matrix Math. I'm going to edit. My matrix is now going to be a 2 by 2, right? So 2 by 2. And what are the values of that original matrix? It was 3, -2, -1, 1. Okay, so I've stored it in here. I'm going to quit. So I'm here. And the easiest way to get your inverse matrix, go to matrix, grab that first guy, exponent, -1, press enter, and there it is.
Wait, I just plug it all in.
No.
And then put row
No! So there's so many different ways to do it. That's what makes math so freaking cool.
She figured this out already.
Okay? Okay. I don't think we're gonna have time. How much time do we have left? We have 10 minutes left? Okay. Here, do this then. Find the inverse of this guy. Any method you want, except the calculator.
Hey, Mr. Lucas, we just did that one though.
Is that what we just did? Yeah. Oh, here you go then.
Wait, how do you do cross multiplication?
No, this is only gonna be for a 2 by 2. That's why I like the other one. Do it with your calculator real quick. Do this one with your calculator real quick.
Mr. Munoz,
What's up?
my computer's dying.
Put it in the chart. Oh no, someone dropped it.
Look, bro. Look, bro.
You're
What? No solution.
they say?
No drama. That's what
Does your bottom say -1, 1, 2?
Yes.
I missed it. What is this? So like,
Does your bottom say -1, 1, 2?
negative 1, 1, 2.
Oh, okay, I got it.
Is that bad? I mean, like, that's it.
Oh, you're in that. You're with the, you're in the imaginary realm. Why do people change these? Okay, hey. Waterfalls. Cell phones. So, your textbook has offered you this formula. Disclaimer, full disclaimer. That's only going to work for you if you have a 2x2 system. Okay? Because like Maddie's like, when she did the 3, well, how do I do that with the 3x3? You don't. You can't do this with 3x3. This is only for 2x2. The method I showed you here, where you have to do the identity and then swap them, any one of them. Okay? Or you're going to have to resort to your okay? Alright, cool beans. So here's what's going to happen. We're going to do the last section on Monday. That will give us Tuesday, Wednesday, Thursday. Study test Friday. Monday, Tuesday, Wednesday we'll review for the final exam. Just an FYI, your final exam is not on Math Excel. It's going to be a paper test.
Our final.
Like, what about
There's only that. Let me turn this off because we don't need to say all this on the recording.
Wait, so we don't